Hi, this video is about the smallest possible amount of electric charge. We start with an experiment in 1909 conducted by Robert A. Millikan and Harvey Fletcher. And I wanted to tell you a little bit about this experiment. It's got a strange setup. So you've got a spray bottle here with oil in it, and it's a particular kind of oil that won't vaporize when exposed to heat or anything like that. They spray this oil into this open space and let it fall by gravity down through a hole in a metal plate. And it falls through this hole towards the ground, and there at the bottom is another metal plate. These two metal plates are connected to a battery of some sort, where the top plate has a positive charge and the bottom plate has a negative charge. So when the battery is connected, it creates an electric field in the middle here, or some kind of electric zone where these oil drops will fall. And by shooting these oil droplets with X-rays, you can cause them to acquire negative charges. And so they fall with a negative charge. And they adjusted, Millikan and Fletcher adjusted the voltage of this battery and adjusted the plates until the droplets could float. In other words, they were falling down due to gravity, but there was an upward electrical force on them that balanced out the downward force of gravity, and they just suspended in air. And so by doing this, the oil droplets, they discovered, would only fall at integer multiples of some base speed. For example, if they fell at a speed of v, then they could only ever fall at 2v, 3v, 4v. They could never go 2.6v. It was always some integer multiple of some base speed that they would fall with. And this only occurred when they actually turned the plates on, because otherwise they would just fall at a terminal velocity and it wasn't very interesting. But when you turn these electrical plates on, you realize you were really testing for their electric charge. How much they were influenced by the plates depended on how much electric charge was on each droplet. And so by deducing all of this, it implied that the charges possessed integer multiples of some base or fundamental amount of charge. And it's kind of like our money system. Just as our money is made up of increments of a fundamental unit, the penny, electric charge is made up of increments of the smallest or fundamental charge. So just how much is this small fundamental electric charge? So again, money is measured in dollars, and the smallest possible amount of money is $0.01. That would be 1 cent, 1 penny. Charge is measured in coulombs, as we've talked about in a previous video. The smallest possible amount of charge then is very, very small. This would be the smallest possible electric charge. It's like the penny, but for electric charge. And it's got 18 zeros here, and then a 1. And to abbreviate that, you can write it in scientific notation. So this is what it is in scientific notation. The smallest, most fundamental electric charge is 1.602 times 10 to the negative 19 coulombs. Now, why is it so small? It all has to do with the definition of a coulomb. Whenever the coulomb unit was, invented to be used for electrical things that we see, the people who used that unit had no idea that it was connected to atoms and electrons. They were just experimenting with electric phenomena that they saw. And so this is really an indication of just how tiny electrons are. They have such a tiny amount of charge compared to our everyday amount of charge. So Millikan and Fletcher believed that they had measured the charge of a single electron in their oil drop experiment. And they were correct. The charge of an electron, today we know, is negative 1.602 times 10 to the negative 19 coulombs. This lowercase q here is used to symbolize the quantity of charge in physics. And the charge of a proton is actually just the same amount, same magnitude, but it's positive. That's because they always balance out in atoms. And so the charge of a proton is positive 1.602 times 10 to the negative 19. Now these are super tiny charges, and normally in our everyday experience, if we can feel like static from something or feel an electric charge, most of those charges we can feel are on the order of 1 times 10 to the negative 6 coulombs, which in physics, 10 to the negative 6 can be represented with micro. And so we can say 1 microcoulomb is about the order of the charges that we experience. It can be a little more or less. Like a lightning bolt might be like 15 coulombs of charge, which is a lot. So coulombs are a very big unit, and we don't usually deal with charges in that amount, especially when we're dealing with staticky kinds of electricity. So that's all I've got for you in this video. Remember, shortcuts make long delays.